All right, let's talk about something huge. We're going to dive into two concepts that are, and I mean this, absolutely essential for taking your Java code from, a basic script to something truly professional. We're talking about mastering exceptions and strings.
So tell me if this sounds familiar. You've been coding for hours, you've written this piece of code that you think is just perfect. It compiles, it runs, everything looks great, and then bam, the second it touches some real-world data, the whole thing just falls over. We've all been there, right?
And that's really the heart of the problem, isn't it? Our nice, clean, logical code has to go out and face the absolute chaos of the real world. Think about it. Bad user input, files that are supposed to be there but aren't, spotty network connections. The goal isn't to pretend that chaos doesn't exist, it's to build a shield for our code so it can survive.
So let's start right there with what happens when things go wrong. We really need to change how we think about this. Errors aren't failures, not really. They're just events. Events that we can and absolutely should plan for. Now in Java, when one of these disruptive things happens, we call it an exception. You can think of it like Java literally throwing up a red flag, shouting, "Whoa, hold on, something unexpected just happened and we can't just continue on like normal."
And this is the whole game. Instead of just letting that red flag bring the whole program crashing down, what if we could teach our code to actually see that flag, deal with the problem gracefully, and then just keep going? That's the real difference between code that's fragile and code that's resilient. And lucky for us, Java gives us this incredibly powerful tool to do exactly that. We call it the exception handling safety net. And believe me, it is your best friend when you're trying to build stable applications.
The whole thing is built around three simple keywords: try, catch, and finally. Okay, here's an analogy. Imagine you're a chef. You try to flip a pancake. That's the risky part. If you drop it on the floor, the catch block is your plan B. You know, how you handle the mess. And the finally block, that's you cleaning the kitchen. It happens no matter what, whether you nailed the pancake flip or you've got a disaster on the floor.
Now, Java's smart about this. It splits exceptions into two big categories. First, you've got checked exceptions. These are problems that are kind of predictable, like a file not being where you expect it to be. The compiler actually forces you to have a plan for these. Then you have unchecked exceptions. These are usually bugs in your own logic, like trying to divide by zero. The compiler doesn't make you handle these because really you should just fix the bug. It's a key difference between external problems and your own internal mistakes.
Okay, so we've built our safety net for when things go wrong. But a lot of those errors happen when we're trying to process data. Right, and that brings us to our second pillar, mastering Java's strings. Because let me tell you, handling text the right way is every bit as important as handling errors.
I know what you might be thinking. It's just text. How hard can that be? But seriously, just stop and think for a second. Usernames, passwords, comments, configuration files, pulling data from an API. Text is literally everywhere. Being able to manage it well isn't just a nice skill to have, it's a non-negotiable part of being a good developer.
At its most basic level, a Java string is just what it says it is, a sequence of characters. It's how we hold and work with text. But lurking just beneath that simple definition is a really important design choice that affects everything from performance to how you actually write your code. And here it is, a super critical concept. Standard Java strings are immutable. That means once you create one, its value can never, ever be changed. It's like a message carved into a stone tablet. It's permanent. Now, this makes your code a lot safer and more predictable. But if you need to make lots of changes to some text, creating a whole new object every single time is super inefficient. And that's why we have mutable options like String Builder. Think of that one like a whiteboard. You can erase and rewrite things on the fly without needing a new board every time.
On top of that, Java gives you this fantastic toolkit for actually working with strings. Methods like finding the length, grabbing a character at a certain spot, pulling out a substring, or checking if two strings are equal. These are the everyday tools you're going to use constantly to slice and dice and compare text.
So let's bring this all home. We've got handling errors gracefully on one side and manipulating text efficiently on the other. Why are these two things so incredibly fundamental to building real, professional software? Because let's be real, this is the stuff that bridges the gap between a classroom project and a real-world application. This isn't just about passing a test. These are the absolute core building blocks you need to create software that people can actually count on. Software that's secure, that's stable, and that doesn't just fall apart at the first sign of trouble.
And hey, don't just take my word for it. The source material we're looking at today calls these skills pivotal for practical software development. Getting a handle on them is a major step up for any developer.
And check this out, this isn't some niche, specialized skill. It doesn't matter if you're going into web development, data analysis, mobile apps, or general software engineering. Being great at handling exceptions and strings is required everywhere. It is the bedrock of quality software in every single one of these fields. No exceptions.
At the end of the day, this is why it all matters so much. Our goal isn't just to write code that works when everything is perfect. It's to build software that can handle the messy real world, that protects the data it's responsible for, and that gives the person using it a stable, positive experience.
So, I'm going to leave you with one final question to chew on. Thinking about your own code, your own projects, what's the first fragile part that you're going to make robust?